So this is a presentation I've put together for Friday Year 11 revision, and the topic is on both the combined science and triple science papers, and additionally it's also in chemistry and physics. So there's a good bit of overlap here. So I'm going to run through the history of atomic structure, and we'll see how much you can remember at the end of this short presentation. So I'm expecting you to know most of the scientists involved, and you should be able to describe and explain how the model of the atom has changed over time. So here are the scientists involved. You should have heard of some of them. Some of you may have heard of most of them, and we'll run through each one in turn. So John Dalton, he pretty much kick-started modern day physics, chemistry in terms of our understanding of the atom. He reused a term that was originally put forward in ancient Greek times, which meant that a particle was indivisible, couldn't be split, and that was called the atom. So he reused this word atom for that purpose. And his model of the atom was based upon lots of measurements that he took of atomic weights of atoms when he tried to split particles into their component parts or rejoin them together to make compounds. So his model of the atom said that atoms are solids, they can't be destroyed, they can't be made. Atoms of the same element have the same mass. Atoms of different elements have different masses, and they can join together to make larger particles. His chemical symbols that he used were rather strange and rather complicated, and we've since stitched that. So that's John Dalton, and that's pretty much at the start of the 19th century. So we're talking about 1800s, early 1800s. John Jacob Berzelius picks up the baton, and he was a Swedish scientist from a fairly poor background. He looked at John Dalton's work and knew of John Dalton, and he improved upon John Dalton's work by taking really super accurate measurements of the weights of the atoms. And if you look at his data in the table, then you can see that that pretty much matches the modern day periodic table. He improved upon John Dalton's work by proposing that atoms are spherical. Atoms are always the same size, but that they combine together in fixed proportions. Now, he learnt this from the work of another scientist, Sir Humphrey Davies, and he knew, for example, that water contained 2 parts hydrogen to 1 part oxygen, and from that, he was able to ascertain the exact weights of hydrogen and oxygen. The letters that we use nowadays in the periodic table are due to John Jacob Berzelius. He's the one that originally proposed those. I'm sure you will remember J.J. Thomson. He discovered the electron in 1897, and from that he realized that the atom must consist of other things. Therefore, it's not indivisible. Therefore, it can be split. They knew that the atom was neutral. It had no charge. But J.J. Thomson showed that by firing particles at the atom, through careful observations, he showed that negative particles left the atom. So he suggested a plum pudding model where the whole atom is positive and it has these negative electrons embedded in the atom. He also showed that the mass of an electron was absolutely tiny, 0.0005 of a proton, or as you can see, 1 over 1,840. He was very proud of his plum pudding model, and he was known to arrange parties with his students, and after a feast at Cambridge University, all of his students got served plum puddings for pudding. Now, one of J.J. Thomson's students was Ernest Rutherford, and he came from New Zealand, and he gained a scholarship to work at Cambridge, much like J.J. Thomson actually, and he believed Thomson's plum pudding model, but he decided he would try and conduct an experiment to prove that the plum pudding model was real. So what he did is a famous experiment involving gold foil and alpha particles. I'll show you the experiment on the next slide. So what he did, he found an alpha source with a tiny little hole in it. He allowed the alpha particles out through the tiny little hole, and they moved through and hit a gold foil, a very, very thin gold foil. And what he observed was that most of the particles went straight through the gold foil. Now, this is something he did predict. But very, very few particles deflected off at an angle, and even less came straight back. And he couldn't quite work that out. The plum pudding model wouldn't allow for that to happen. So he realized that the plum pudding model must be incorrect. He realized that most of the atom must be empty space, but there must be a tiny, tiny center of the atom, which must be solid because these alpha particles deflected off of it. And it must be positive because the alpha particles are positive. So he proposed his nuclear model, whereby you have a nucleus in the middle of positive charge where all the mass is, surrounded by negative electrons.